Our next method is completing the square. Before we start solving quadratic equations by completing the square, I would like to do a little bit of investigation on the patterns we can find in perfect squares. We have x plus 1 quantity squared, x plus 2 quantity squared, and so on and so forth. If I take x plus 1 quantity squared, that means x plus 1 times x plus 1, and then when I distribute, I'm getting x squared plus 1x plus 1x plus 1. I can combine my two middle terms to get x squared plus 2x plus 1. We're going to work the first four problems similarly, but a little bit faster. X plus 2 squared turns out to be x squared plus 4x plus 4. And you're welcome to check these at your leisure. But what I'd like to do is I'd like to look at the patterns here. What do you notice that's the same in each one of these expanded perfect squares? One thing students will usually let me know is they'll identify that the first term is always going to be x squared. Another pattern that students usually see is the second term is going up in pairs, 2x, 4x, 6x, 8x. But also I want to relate it to the binomial that's being squared. If you notice, the number 2, 4, 6, and 8 are all double 1, 2, 3, and 4, the numbers we found in the binomial squared. So what we have here is double this value found in the binomial. And then the last column, the 1, 4, 9, 16, we notice that that's the value that you found in the binomial squared. So once you notice that these patterns, I want you to try the next two on your own, x plus 7 quantity squared and x minus 8 quantity squared. Pause the video and see if you can work those out using the pattern yourself. Did you get the following perfect square expansions? X squared plus 14x plus 49. 14 is double 7. 49 is 7 squared. Similarly with the x minus 8 squared, negative 16 is negative 8 doubled. Notice that it still works for negatives. Negative 8 times 2 is negative 16. It is the value doubled. For the last term, we have negative 8 squared, which is positive 64. So now we've done a little investigation on perfect squares. The last two problems are really what we're trying to get to. I want to see if you can look at the first two terms of the expansion of the perfect square and see if you can fill in the blanks. Pause the video and see if you can fill in the blanks. For the first problem, we have x squared plus 12x as our expansion, and I'm trying to figure out what binomial is being squared. I know that 12x is double, so I'm going to take half of 12x and get positive 6. Once I have that value, I can square 6 and get 36. On the next problem, I'm going to similarly divide negative 18x by 2 and get negative 9, and then I can square negative 9 to get 81. Hopefully the pattern you noticed is that we take the linear term's coefficient, the 12, and we divided it by 2. Then after we divided it by 2 to get the last blank, or the constant term, we took that value and we squared the value. This divide by 2 and square is very, very important. We're going to be using that on every single completing the square problem. Divide by 2 and square, divide by 2 and square. We're going to be using that an awful lot. Now let's look at the instructions how to use completing the square. The first thing I'd like to know is when I should use completing the square method. I want you to understand that this method will always work. But I would only use this method if I was unable to factor or to use the square root method. We're going to try those two options first before we use completing the square. That's going to be your fastest option. Although completing the square will always work, the most convenient time to use completing the square is when our equations have a is equal to 1 and where b is even. When a is 1 and b is even, your numbers come out very nice on your completing the square method, although this method will always work. So from standard form, we want to make a equal to 1 by dividing each term by the coefficient a. Next, I'd like to move the constant term to the right side of the equation and add 2 blanks to each side. We now complete the square by dividing the linear term by 2 and squaring that value. Put this value in the blanks. The right side will now factor into a perfect square. Finish solving by using the square root method. So again, remember, this method will always work, but it is most convenient when a is 1 and b is even. Let's try a few examples. For our first problem, x squared plus 10x plus 21. First of all, is it in standard form? Yes, it is, because it's equal to 0. Secondly, is a equal to 1? And yes, it is. There is no coefficient in front of the x squared, therefore we have a 1 there. The next is b even. And that is also a yes, because our 10 is even. Our linear term's coefficient is even. So this is a very convenient problem for completing the square. In standard form, my a is already 1, so therefore I do not have to divide by a in order to make a 1. If I did divide by a, it would result in the same equation. So this is a little redundant. Because a was already 1, we didn't really have to do that step. Next step says move the constant term to the right side of the equation, meaning I want to move this 21 to the opposite side. The next step says add blanks to each side of the equation. To fill in these blanks, I'm going to complete the square by dividing the linear term by 2 and square. Divide the linear term by 2. My linear term is 10, so when I divide that value by 2, I'm getting 5. I like to put that right inside my binomial squared because I know that value is going to be there, just like we practiced on the last page. And how did I do that? I divided by 2. Now, x squared plus 10x does not factor into x plus 5 quantity squared until I fill in that blank. And the way I'm going to fill in that blank is I'm going to square my value. I divided by 2 to get 5, and now I would like to square 5 to get 25. So when I put the 25 there, this trinomial does factor into this binomial squared. I've unbalanced my equation here. I added 25 to the left-hand side, and I'm actually not allowed to do that unless I balance my equation by adding a 25 to the right-hand side, which is why I have a blank on the left and the right. The additive property of equality says I'm allowed to add any value I want to both sides of the equation. I conveniently chose a 25 so I could turn my trinomial into a binomial squared. When I combine like terms on the right-hand side, negative 21 plus 25 is 4. And what I have now is an expression squared equals a value, which tells us we can use square root method. So I'm going to square root both sides. And we remember that every time we take the square root of both sides, we have to take the plus or minus part. And then I finish solving this. So my answer is x equals -5 plus or minus 2. I cannot leave my answer as -5 plus or minus 2 because I actually know what -5 plus 2 is. I also know what -5 minus 2 is, so I actually have to finish evaluating those. -5 plus 2 is -3. -5 minus 2 is -7. So my solution set is -3 and -7. And you can check that at your leisure. On the next equation, 2x squared plus 14x plus 4 equals 0, I want to check some items. Am I in standard form? Yes, all my terms are on the left-hand side. Does a equal 1? Well, no, a does not equal 1, although I know how to get rid of that. Because it's already in standard form, all I have to do is divide every term by a, as listed in our steps, which gets me x squared plus 7x plus 2 equals 0. So now a does equal 1. Okay, my next question is b even? Well, again, this is now no. My b is now 7, and that's odd. Can I still do completing the square method on this problem? Yes, it's just not going to be as convenient, and you'll see why. We'll get some fractions in here, which aren't that fun. So if you had your option to choose your method, I might not want to choose completing the square because b is not even. Although I want you to understand that it does work, and I'm going to show you how it does work. We're going to follow the same steps. Move the constant term to the right-hand side, and leave blanks on both sides. To complete my square, I'm going to use my divide by 2 and square step. I take 7 and I divide 7 by 2 to get 7/2, and that's where our fraction comes in, which is not the most pleasant value to work with, but it still works. So I took 7 divided by 2 to get 7/2. 7/2, I need to square 7/2 to get 49/4. Now, this trinomial, x squared plus 7x plus 49/4, does indeed factor into x plus 7/2 squared. Please don't forget your square outside the binomial. I've unbalanced my equation by adding 49/4 to the left-hand side. To keep my equation balanced, I'm going to have to add 49/4 to the right-hand side. I'm also going to have to get a common denominator over here, common denominator of 4. So I'm going to multiply the first fraction by 4 in the numerator and the denominator. My result is 41/4 on the right-hand side. Notice that x plus 7 quantity squared is an expression squared, and it's isolated, which allows me to finish my problem using the square root method. So I'm going to now take the square root of both sides, leaving me just the expression x plus 7/2 on the left-hand side equals, and every time you take the square root of both sides, you have to take the plus or minus part, leaving me with plus or minus square root of 41 over the square root of 4. Now the square root of 4 reduces to 2. And my last step is to isolate the x by subtracting 7/2. X equals -7/2 plus or minus the square root of 41 over 2. We can write that -7/2 plus or minus the square root of 41 over 2. Or you can write it -7 plus or minus the square root of 41 all over 2. On our last problem, 3x squared minus 18x plus 21 equals 0. Am I in standard form? Does it equal 0? And in this case, yes, it does. Does a equal 1? Well, not right now. And the way I'm going to get a equal to 1 is I'm going to divide each term by the coefficient a, leaving me with x squared minus 6x plus 7 equals 0. Now, is a 1? And now I can say yes, a is 1. Is B even? Well, B is 6 and 6 is even, so this is a yes. So this is a very good candidate for completing the square because A is now 1 and B is even. I'm going to move the constant term, the 7, to the right-hand side, leaving me with x squared minus 6x. Please leave a blank on both sides because we're going to come back and fill that in or complete our square. I would like x squared plus 6x plus something to factor into a binomial squared. And the binomial that I would like it to factor into is x minus 3 squared. I got that by taking negative 6 and dividing it by 2. In order for this to truly factor into x minus 3 squared, I need to complete my square. And the way I do that is square my value negative 3. Negative 3 squared is 9. Notice that the value that we add to both sides is always positive because when you square a value, it turns out always to be positive. To balance my equation, if I add 9 to the left, you have to then add 9 to the right. And now my equation is in the form expression squared equals number, which I can solve using the square root method. Notice that the x minus 3 here is now isolated. So now I'm going to take the square root of both sides, leaving me with x minus 3 equals plus or minus the square root of 2. And to isolate x, I add 3. X equals 3 plus or minus the square root of 2, which is my solution. Our last method is quadratic formula. I want you to know that the quadratic formula will always work, similar to completing the square, but I only use this as a last resort. I always try factoring first. If I can use square root method, I'll do that. Next, if A is 1 and B is even, then I'll try completing the square. But if it is not convenient to use any of the other 3 methods, I know I can use quadratic formula. So our steps to use quadratic formula are to put the quadratic formula in standard form, which is ax squared plus bx plus c equals 0. And then I want to identify the values of a, b, and c. Third, I will substitute the values into the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then I'm going to reduce it. Some of my students will ask me, do I really need to memorize the quadratic formula, or will you put that on the test? It will not be on the test. That is something that you need to know. We'll be using it several times all throughout the semester, and you need to have this handy, so I do want you to memorize that. And if you think it's too hard, just take a look at this.
This is the quadratic formula. X equals negative b plus or minus the square root p so minus RAC over 2a.
That was a 5-year-old and he already knows the quadratic formula. And if you're not impressed yet, take a look at this.
X equals negative b plus or minus the square root equal minus 5c over 2a.
So if a 3-year-old and a 5-year-old can memorize the quadratic formula, I think so can you. So let's go ahead and work on some of these problems. The first problem we're going to practice the quadratic formula on is x squared plus 9x plus 11 equals 3x minus 2. And the first question I want to ask myself is this equation in standard form? Well, the answer is no, it's not. And the reason it's not in standard form is because it does not equal 0 on either the left or the right. So in order to make it equal to 0 and have all the terms on one side, I'm going to come in and I'm going to subtract 3x from both sides. At the same time, I'm also going to add 2 to both sides. And I'm left with x squared plus 6x plus 13 equals 0. Now I have it in standard form, so I would like to list out what my a, my b, and my c values are. My a is going to be 1 because that's the coefficient in front of x squared. My b is a positive 6 because that's in front of the x, and my constant is 13, so that's c. I'm going to be taking these three values for a, b, and c and substituting it into the quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So when I substitute the values, I get x equals negative b, or the opposite of b. My b happens to be positive 6, so I want to take the opposite of positive 6, or negative 6, plus or minus the square root of b squared. b is 6, so 6 squared is 36. I like to do that part in my head so I don't accidentally make mistakes, especially when I have negatives for b. Minus 4 times a, but a is 1, times c, but c is 13. All over 2 times a, which is 1. When I reduce, I would like to first focus on the inside of the radical. So I'm going to leave negative 6 plus or minus the same. On the denominator, 2 times 1 is just 2. And I want to focus in on reducing the radicand, or inside the radical. So I have 4 times 1 times 13, which is 52. That leaves me 36 minus 52. When I subtract inside the radical, I have 36 minus 52, which is negative 16. And the square root of negative 16 is 4i. Now, I'm almost done here. I still need to reduce because both 6 and 4, the coefficients in the numerator, can both be divided by 2. So I'd like to factor out a 2 out of the numerator, which leaves me with negative 3 plus or minus 2i over 2. The 2 that I've factored out of the numerator and the 2 in the denominator divide out to 1, so my answer is x equals negative 3 plus or minus 2i. Notice I still have two answers, just like in my previous problem. Because I have a quadratic equation, I'm still having two answers, negative 3 plus 2i and negative 3 minus 2i. For my last problem, I'm already in standard form because I'm already set equal to 0, so I can go ahead and identify my a, my b, and my c from my quadratic equation. A is 9, b is negative 18, and c is 7. I'm going to write down the quadratic formula one more time just so you can see it close. You might consider doing that on your homework until you have it memorized. So I have x equals negative b. Now b already is negative 18, so the opposite of negative 18 turns out to be just positive 18, which we'll write in the next step. Plus or minus the square root of b squared. Negative 18 squared is positive 324. Minus 4 times a, which is 9, times c, which is 7, all over 2 times a, which is 9. So the opposite of negative 18, like we said earlier, was positive 18, plus or minus the square root. Now I need to reduce under the radical. 4 times 9 times 7 is 252. And 324 minus 252, the square root of 324 minus 252 is 72 under the radical symbol. We need to reduce the square root of 72. Off to the side of my paper, I remember that the square root of 72 is 36 times 2. And the square root of 36 is 6. And the square root of 2 is just the square root of 2. So the square root of 72 reduces to 6 square roots of 2. And finally, I have 18 over 18 plus or minus 6 root 2 over 18, which is 1 plus or minus the square root of 2 over 3, which is my solution set. Lastly, I'd like to summarize how to choose the best method. We mentioned this as we went along. Now that we have all 4 methods, I'd like you to follow this order. First step, always try to factor first. Secondly, if b is equal to 0, or if you have an expression already squared equals some number, then I want you to use the square root method. If neither of those two things work, and a is 1, or you can get a to be 1, and b is even, then it is convenient to use completing the square. But remember, completing the square is always an option. Even if b isn't even or a is 1, you can still use completing the square. And as a last resort, use quadratic formula, which will solve any quadratic equation. I hope this helped you review solving quadratic equations.